Welcome back. Today we're going to start looking at Chapter 4. We're going to start that with Section 1. Now, Chapter 4 is all about systems of equations and inequalities. This first section, we're going to look at solving them by graphing. And you might be wondering, what is a system of equations? A system of equations is where we have multiple equations that are happening at the same time. And we'll see some examples of why that might be the case. But a lot of times when we're comparing things, like if we make a separate equation for each of them, then we get a system of equations and we can see where is one bigger than, less than, where they equal, things like that. So actually on the background here, we have a system of equations where one of our lines, a red line, and one of them is a blue line. The solution that we are going to look for a system of equations is right here where they intersect. So we graph both lines, then we're just looking for where they intersect. So let's see how we can do that. As you can imagine, this is going to use heavily the ability to graph lines. So if you're good with that, good, this will be a bit easy. If you're struggling with that, this is extra practice for that. Our learning targets for this topic. I can use graphs to find approximate solutions to systems of equations. Really, all we ever find by graphing is an approximate solution. We'll then plug it back in to see if it works. There are times when, yeah, it'll be good, and there are times when it'll be close, but we can't get it close enough to really work. And we'll have other methods of solving systems of equations later on in this chapter. So, to solve a system of equations by graphing, we get our system of equations, just two equations, and we're going to graph them. So here we have a graph. One of the biggest keys to success is use graph paper. Use a straight edge. The more accurate your graph is, the easier these problems are and the better your answers will be. If you're just kind of like throwing things on there, your lines aren't straight or very accurate, this is going to be very difficult. So having graph paper and a straight edge is super, super useful. So we have the first one. I'm going to color code my graphs. This first one will be red. We have y equals negative 2x minus 4. So we'll start out, our y-intercept is negative 4. And then our slope is negative 2. So we go down 2 over 1, down 2 over 1. Or we could go up to backwards 1, up to backwards 1, up to backwards 1. And then draw our line. I don't particularly have a straight edge that works on my computer here. I'm going to try one, but I think this is going to give us some extra stuff, and it did not let me write very well either. That's with a straight edge. That's a little bit awkward. And let's make the second one blue. So that's going to be 0.5x or 1/2 x plus 6. We're going to start out at 6. 1/2, we go up 1 over 2. But if we keep making points this direction, that's getting away from the line. So let's go back, down 1, backwards 2, down 1, backwards 2. Right about there. I'm going to try this without a straight edge. I think I was actually better without a straight edge. Computer and paper are very different. So now our solution looks like it's right about there. And what does that point look like? Well, my red line got a little bit off, but that looks a lot like it might be the point negative 4, 4. Looks like the point negative 4, 4. Now we're going to plug it in because it could be negative 4, 4. It could be negative 3.5, 4. It could be negative 3.9 comma 4. Chances are for these first ones, it's going to be right on a nice point. So let's try negative 4 comma 4. To test this, we are going to plug that point in to both of our equations. If it is the solution, it will make both of our equations work. So in that first one, we'll plug in negative 4 for x and 4 for y. So we'll have 4 equals negative 2 times negative 4 minus 4. Let's see, negative 2 times negative 4 is 8. So we have 8 minus 4, and 8 minus 4 is 4. So that one works. Let's try it in the blue one. So we'll go 4 equals 0.5 times negative 4 plus 6. 0.5 times negative 4 is negative 2. Negative 2 plus 6 is 4. So that one works. So our solution is in fact negative 4 comma 4. So again, all we're doing here is we're graphing both lines on the same graph. Do it carefully, do it accurately, and then we're looking to see if they, like where they intersect. Plug that point into both of the equations to make sure that it's right. That tests both whether it's off by just a little bit, because maybe it's not exactly at that point, maybe it's close. This is an approximation. It also checks to make sure that something horrible didn't happen in the graphing process. So we have a couple for you to try. So you're going to want a piece of paper and a pencil. Ideally, a piece of graph paper if you have some. That's hugely useful. So we're going to have y equals 1/2 x minus 2 and y equals 3x minus 7. This is the first one that you're going to try. So pause the video, make sure you have your paper pencil, graph these two lines. This is graphing practice as well. So graph the two lines, then unpause, and we'll see how it worked. Did you do it? If you didn't, pause the video. This is part of the learning process. Trying it on your own is very important. So once you're done with that, let's look at this one. We have the top line, y equals 1/2 x minus 2, so we're going to start out at negative 2. The slope is 1/2, so we go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. We can go down 1 backwards 2, down 1 backwards 2, down 1 backwards 2, down 1 backwards 2. Connect the dots. I think I'm better without the straight edge on my computer. And then we have the other one. We start at negative 7. Then we go a slope of 3, so we're going to go up 3 over 1, up 3 over 1. Well, that's where it hits, so we don't need to really continue past there. And it looks like it hits at 2 comma negative 1, and there is a point there for both of these, so chances are this will work. So let's try it. So we'll have negative 1 equals 1/2 times the x was 2 minus 2. 1/2 times 2 is 1, and 1 minus 2 is negative 1. Negative 1 does in fact equal negative 1. Let's try it for the blue line. So we'll have negative 1 equals 3 times the x, which is 2, minus 7. 3 times 2 is 6, and 6 minus 7 is negative 1, so it works for that one. So our solution is 2 comma negative 1. Did you do it well? Did you get it? Did you make a mistake? Maybe in graphing? Well, if you did, this is your lucky chance because you get to have another practice one. All right, so we have y equals negative 2x minus 4 and y equals 0.5x plus 6. So go ahead, pause the video and try this one. And then when you're ready, push play and we'll take a look at it. All right, how do you think you did? Did you get a nice number at this point? The answers are probably going to be nice. Maybe not. We'll see. So, first one, red. So we'll start out at -4. Slope is -2, so we'll go down 2 over 1, down 2 over 1, down 2 over 1. Let's go up 2, backwards 1, up 2, backwards 1, up 2, backwards 1. For me specifically, since I don't have a straight edge to use, having a bunch of points is super helpful. You only really need 2 to make a line. 3 is good, so just adds to it. And 0.5 plus 6, so we'll start out at 6. And then 0.5 is 1/2, so that's up 1 over 2, but that's going the wrong way, so let's go down 1, backwards 2, down 1, backwards 2. Hey, those 2 points look like they're on the same place. So we're looking at this point right here, which is -4, 4. I think was this one the first one that we did? Did I accidentally put the same question twice? That's embarrassing. I meant to do a different problem. This was supposed to be 2x plus 10 and -1/4 x plus 1. Oh well. Well, this was the first one. We don't need to plug it in because we already did that. We know that that works. Sorry, I cheated you out of a problem that you could have done on your own. If you go to your notes, like do the notes assignment, you can do what it was supposed to be as well. All right. Well, so moving on, we have some other things that can happen. So far, what we've looked at is kind of like the normal thing that happens. They intersect, and 2 lines can intersect exactly 1 time. But there's a couple other options. They could intersect not at all, which would make it so there's no solutions, or they could intersect an infinite number of times, which would make infinitely many solutions. So right now we're going to take a look at those and what those are. So the first one, we have 15x plus 5y equals 25, and y equals 5 minus 3x. So if we graph these, this top one is in standard form, so I'm going to leave it in standard form, and we're going to graph it using intercepts. So if x equals 0, we have 5y equals 25. So if x equals 0, y equals 5. And then if y equals 0, we have 15x equals 25. We can divide by 15, x equals 25 fifteenths. We can divide those by 5, so that reduces to 5/3, which is 1 2/3. And then we can draw that one. And now the blue one, we're going to start out at 5. Oh, hey, look, that's where they intersect. Then we're going to go down 3 over 1. Oh, and they intersect there. Down 3 over 1, and they intersect there. And so these two have infinitely many solutions. And why is that? It's because they are the same line. How are they the same line? They look different. Oh, sure they do. But if we take that red equation, 15x plus 5y equals 25, and we put it into slope-intercept form, we can subtract the 15x minus 15x, so we get 5y equals 25 minus 15x. Divide everything by 5. We get y equals 25 over 5 is 5, minus 15 over 5 is 3x, which is the same thing. So if the lines are the same, then you have infinitely many solutions because it's the same line and it graphs right on top of itself. The other option, so that's infinitely many solutions. This one's probably going to have 0 solutions, just because that's what we're talking about here. If we take the first one, oh, these are both in standard form, so we'll do intercepts. So when x equals 0, y equals 6. And when y equals 0, we have negative 2x equals 6. So we can divide to get x equals negative 3. And then the second one, if x equals 0, 2y equals 8, so y equals 4. And if y equals 0, we get negative 4x equals 8. Divide by negative 4, x equals negative 2. What do you notice about these two lines? I notice that they're parallel, which means they don't intersect, which means we have no solution because they are parallel lines. To test that, we could put them into slope-intercept form. The red one, y minus 2x equals 6, we can add the 2x. So y equals 2x plus 6. And for the blue one, we have negative 4x plus 2y equals 8. We can add the 4x to get 2y equals 4x plus 8. Divide everything by 2. Y equals 2x plus 4. Now, how can we tell that lines are parallel? Parallel lines have the same slope. In this case, the slope of both of these is 2. So these lines are parallel, and so they'll never intersect. So our lines, our system of equations, they could have one solution where they intersect. That's like the normal. They could be the same line and have infinitely many solutions, or they can be parallel lines and have no solutions. We find them all the same. So how we do things doesn't change. It's just if one of these shows up, you need to know that those are options. Writing a system of equations. So to write a system of equations, we just need to write two different equations. So here we have Monisha and Holly have 14 days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Monisha both maintain their reading plans, when will Holly catch up with Monisha, and then who will finish reading the novel first? So the first thing we need to do is we need to write our equations. So each person will have an equation. We'll have a Monisha equation, and we will have a Holly equation. Now, the Monisha equation, Monisha reads 9 pages per day. That's a rate. A rate is a slope. So her page will say y equals, and we'll make x equal the days. We're going to have 9 pages times the number of days. That's how many she's reading, but where did she start? That paragraph doesn't tell us, but we have this other information here. Monisha's on page 96 of 220. So our y-intercept, our starting point, is 96. Holly is going to read 20 pages each day, and she's starting on page 6. So we'll have y equals 20x plus 6. Now we can graph both of these. Now graphing these, with slopes of 9 and 20, that's going to be a big graph. This is where technology can kind of come in handy. because you can graph it, then you can zoom out, you can see where they intersect. Um, and when you have something like this, like to get the graph big enough, it's not going to be hugely accurate as far as at least the y value. I mean, they only have 14 days, so within 2 weeks they should probably catch each other. So the x value is not going to get too big. But this is a 220-page book. I mean, Monicia's y-intercept is 96 already. So, I mean, that's already really big. Like, you'd have to have a really big piece of paper to make this very accurate. But using technology, we can graph it. I just graphed this in Desmos. That's what we use. You can go just desmos.com, hit the graphing calculator button, and you just type your equations in on the left-hand side, and they pop up. So we're looking for this point right here, which we have 5, 6, 7, 8, so it's a little bit more than 8. It actually comes out to be 8.182. At least that's 3 digits of it. If you click on there on Desmos, it'll give that to you. It won't, however, leave that point up when you go to copy the graph, which is what I did. And the y value it gives you is 169.636. So a little over 8 days, they're going to hit about 170 pages. You could plug that in to both of the equations to get 9 times 8.182 plus 96 is going to be about 170. And then 20 times 8.182 plus 6 is also going to be about 170. I mean, there's going to be a little bit of rounding there. So it's not going to come out close, but it's close enough to know that, yes, nothing horrible happened. We didn't type something in wrong. And so in a little over 8 days, they will catch each other. So that is, when will Holly catch up with Monicia? So on day 8. And then the second question is, who will finish reading the novel first? Well, we kind of need to know how many pages are in the novel to know who's going to finish first. Why do we need that? Because if we are on this side of 8 days, Monicia has read more pages than Holly. But if we're above 8 days, Holly's read more pages than Monicia. Because at 8 days, they're the same, but Holly's reading them faster. So, how many pages are in the novel? 220. That one takes a little bit of searching to find. Like, I didn't see it right away because I was looking through the paragraph, but we have page blank of 220. So since there's 220 pages, Holly's going to finish first. So making the equations, again, we look for what is the rate and what is the y-intercept. Making the equations was no different than what we were doing in chapter 2 when we had to write linear equations, except that we have 2 equations to write because we have 2 people that we're writing for. So the first step is look to see which 2 equations you need to write for. In this case, it was people. It could be like 2 cell phone plans. You have to write an equation for each of those. And then you just write the equation using those same things that we've been working on for the past couple chapters. And then solving systems of equations approximately. So we saw this last time. We have the solution to the system of, or in the last slide with Holly and Monisha, we have the solution to the system of equations. So we have our two equations. We can graph this. Now, if you graph this by hand, this one's nice, easy numbers. You can graph it by hand. You can use technology. But what you're going to find is that we get this value right here, which is not at a nice point. If we look at the point, we get 1.286 and negative 4.29 or 0.429. So if we look there, we get that. Now if we plug these numbers in, if we have our, let's see, the red one is the top one. So if we plug these numbers in, we have negative 4.429 equals 2 times 1.286 minus 3. So negative 0.429 equals 2 times 1.286. It's going to be 2, that's 6, 7, 1, 5, 2.572 minus 3. And 2.572 minus 3 is going to give us a negative 0.428. So you have negative 0.429 equals negative 0.428, which is not the same thing. Yes, it's close. As an approximation, this works. In the last slide, when we found out, hey, that's the 8th day, like somewhere in the 8th day, it works. But here, if we were trying to find the exact answer, this doesn't really work. So what happens is that this 1.286 is an approximation of the x value. So what could we do to actually find this answer just a bit better? Well, if we're looking at our two equations, we have y equals 2x minus 3 and y equals negative 5x plus 6. When they intersect, y is going to be the same thing. So since these two y's are going to be the same thing, doesn't it mean that these two things have to be the same, since those are what equals y? It does. So we get 2x minus 3 has to equal negative 5x plus 6. We can solve for x. We can add a 5x over to get 7x minus 3 equals 6. We can add 3 now to get 7x equals 9. Divide by 7, x equals 9/7. Now that's not a particularly nice number, but it's 1.286 or 1.285714, 285714, 285714. Like that part keeps repeating. So it rounds to 1.286. So there we can find x by just making these two things equal. And then to find y, we could plug this into the equations. Now, I would plug it into both just to make sure that something horrible didn't happen. So y will equal 2 times 9/7 minus 3. So when we multiply 2 times 9/7, we just multiply the top to get 18/7 minus 3. Let's make that a common denominator. 3 is 21/7. 18/7 minus 21/7 is negative 3/7, which is going to be about negative 0.429. Let's plug this into the other equation as well. Y equals negative 5 times 9/7 plus 6. So we'll multiply by the top to get negative 45/7 plus 6 is going to be 42/7. Negative 45 plus 42 gives us negative 3 sevenths. So it does come out to be the same both times. We have 9 sevenths, negative 3 sevenths, and that would be our solution to this one, where we were able to find that approximation with the graph, but we weren't able to find that exact value. So if that matters, we do this, and we're going to be looking at this more a little bit later on in the chapter, because this is starting to solve it algebraically. It's a very simplistic one, but we will expand on this idea. But if it doesn't come out nice, you can set the two y's equal to each other and solve. And there you go. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.